Hello students, welcome to the permutation and combination part 5. Till now we have been studying the counting but we are not using the word permutation. So what is permutation? So permutation. Permutation is, just to note the definition, is an arrangement, is an arrangement, arrangement, is an arrangement in a definite order, in a definite order. The definite order of a number of objects, of a number of objects, number of objects taken some, taken some or all at a time. So order, definite order is very important. Taken some or all at a time, that is also important. Suppose you are having number 1, 2, 3, 4, 5, 6, 7 number, and you are taking three numbers and making a number, three digit numbers. So how you will make it? That we have told you, just like, yes, this is 7 way, this is 6 way, and this is 5 way. So answer is 7 into 6 into 5. That is 210. 210 numbers. So suppose you are having n numbers, n numbers. Then here and you are taking r in from that n numbers of objects and taken r at a time, at a time. So that will be n, n minus 1, n minus 2. So up to what? This should be total r. So here n minus 0, here n minus 1. So here n minus r minus 1. So that will be the, so now you do one thing. Yeah, you multiply n minus r, multiply n minus r minus 1, and similarly 3 to 1, and divide that also. N minus r, n minus r minus 1, n minus r minus 2, 3 to 1. So this all will be factorial n. This all will be factorial n and divided by factorial n minus r. So this is called permutation, NPR. N objects are at a time. So what is the theorem 1? So theorem 1 is of permutation is the number of permutation, the number of permutation, the number of permutations of n defined objects, n distinct objects, n distinct objects taken r. R should be less or equal to n at a time, at a time without repetition, without repetition, will be n n minus 1 up to n minus r minus 1. So that is equal to factorial n divided by factorial n minus r, and symbolically it can be written as npr. So what is the npr? Npr, total n object is there with you, and r you have to select and arrange in the order. Arrange in the order means, suppose 1 2 3 4. If you are writing in different order like 2 1 3 4, so this one or this one is different. So this is permutation is nothing but selection and arrangement. Selection and arrangement is called permutation, and only selection is called combination. That we will study later. Now we'll solve some few questions. So 5p2, that means factorial 5 divided by factorial 5 minus 2. That is factorial 5 by factorial 3. So this is 5 4 3 2 1 divided by 3 2 1. So this get cancelled. Answer is 20. Now come to the second question. How many ways there are to arrange the world? How many of these arrangements begin with the R? And how many arrangement can be taking 3 letters at a time? So first, all 5 letters taken at a time. So 5 PR, 5P, 5. So 5P by 5 by factorial 5 divided by factorial 5 minus 5. That is factorial 5. So factorial 5 is 120. Previously, what I taught you, that way also you can. This is 5 4 3 2 1. That is nothing but factorial 5. Now, how many of these letters begin with a R? So, one is fixed. R is fixed. So, now only 4 has to be arranged. So, in 4, how many you have to take 4? So, 4p4. 4p4 is factorial 4. So, factorial 4 is equal to 24. Or you can consider say 4 3 2 1. Now how many arrangement can be made taking 3 at a time? 3 at a time is 5p3. That is factorial 5 divided by factorial 5 minus 3. That is factorial 5 by factorial 2. That is equal to sort. Or you can 3 at a time. So 3 1 2 3. Here 5 4 3 is equal to 60. So whatever method you want to use formula, you can use formula, or you can go by the first principle. That is not an issue. So how many 3-digit number can be formed? 2 4 5 6 if no digit is repeated. So that is 5 numbers. So 5 p 3. So that is factorial 5 divided by factorial 5 minus 3. That is 60. Or you can say solve by this one. At a time you have to take how many digits. Confirm no digit is repeated. 3 digit number. So here it will be 5 base 4 veg, and 3 veg. So that is equal to 16 numbers. So that is also 16 numbers. Now come to the question number 4. How many numbers can be found with a digit taken all at a time? Find the sum of the numbers. So all at a time means factorial 5. 1, 2, 3, 4, 5. Factorial 5. Factorial 5, that means 120. So s- this is 5. So you divide by 5. 24 times it will come. How many times it will come? 24 times. 5 2 yeah 10 5, 24 times. So suppose you are arranging this one 3 4 6 7 8. Now you are arranging 3 4 6 8 7. So each number will come 24 times. This also will come 24 times. If you arrange, if you write all the 120 numbers, then 8 will come 24 times. 7 will also come 24 times. That means at unit place, 8 into 24 plus 7 into 24 plus 6 into 24 plus 4 into 24 and plus 3 into 24 will be there. At 10 place also same, 100 place also same, 1000 place also same. Similarly, it will be like that. So here you can write 24 into 8 plus 7 plus 6 plus 3 plus 3 4 plus 3 into 1. For 10 plus same thing 24 into this one 28. 24 into 28. 8 7 15 15 and 10 25 25 3 28. So 28 will be there. So this will be 24 into 28. Here also 24 into 28 into 10 because it's a 10th place. Then again 24 into 28 into 100. So ultimately, if you add all those, so what will happen? So 24 into 28. So it will start 1 plus 10 plus 100 plus 1000 and plus 10,000. So this will be ultimately 24 into 28 to 1 1 1 1 1. So that will be the answer. If you calculate this, this will be 74 766. So this will be 672 672 into 1111, and that will be equal to 7466592. So this is very interesting question that you must know. Now a teacher has two different books on two different book on English, three different book on physics, and four different books on mathematics. These books are placed on a shelf so that all the books are subject to one subject together. Now how many? So suppose here physics, here English, here English, here physics, and here mathematics. So English 2, this is 3, and this is 4 books are there. So suppose this you take one entity, you take this one entity. So how many ways this can be arranged? That is factorial 3 ways. And this one arranges, suppose this is English 1, this is English 2. So now it can be written English 2, English 1. So this themselves can be arranged in factorial 2 ways. Similarly, physics 1, physics 2, physics 3. This also can be arranged in factorial 3 way. And this also can be arranged in factorial 4 way. So total answer will be this much. So this is 6, this is 2, this is 6, and this is 24. So that will be equal to 1728. Now come to the last question. So NP5. So NP5 you can write factorial n divided by factorial n minus 5 is equal to 42 to factorial n divided by factorial n minus 3. So this get cancelled, and this is factorial n minus 3 divided by factorial n minus 5 is equal to 42. Now factorial n minus 3 is bigger number. So this you can write factorial n minus 3, n minus 4, and factorial n minus 5. Factorial n minus 5. That is get cancelled. So this is 7 into 6. Then n minus 3 is equal to 7. So n is equal to 10. This will be the answer. Now come to the problem where repetition is allowed. Repetition is allowed. So suppose n object is there, you have taken r at a time. At a time. So you have got r place. So here in ways you can arrange, here also n way, here also n way, here also n way. So the total values will be n into n into n into r times. So n to the power r. So if the repetition is allowed, then it should be r times. So this will be the when repetition is allowed. Some few more questions. It is required to arrange 8 book on safe. Find the number of ways to if two specified book are always together. So book B1, B2, B3, B4, B5, B6, B7, and B8. Suppose B7 always be kept together. So total entity will become 7, factorial 7. So this is factorial 7, and two book can be kept as B8 and B7 also. So factorial 7 into factorial 2, that is equal to how much? 100, 100, 10080. Now never together. So never together, if it never together is there, then best way is you make a space like B1, B2, B3, B4, B5, B6. And how many spaces are there in between? 1, 2, 3, 4, 5, 6, 7. If we'll keep B7 and B8 in between, then it will be never together. So B7 and B8, 7 places are there, but and 2 books are there. So how it can be kept? 7P2, 7P2 method. So 7P2 means 7 into 6. Here it can be 7. Here is 6. 6 places are there. 7 into 6. So 7 and B1, B2, B3 themselves can be arranged in factorial 6 way. So that will be 6 into factorial 7. So that is equal to 6 into factorial 7. That is equal to 30240. 30240. Or one more method can be used, but generally that should be avoided, because total how many ways it can be arranged? It can be arranged by factorial 7 way. So how many ways it can be kept together? That is factorial 7 into factorial 2 ways. So how many it can be arranged? 6, sorry, how many it can be arranged? Factorial 8 ways. Factorial 8 ways, no? See, total how many books are there? 8 books there. So that is factorial 8 ways. So you take factorial 7 common, factorial 7 common, then it will be 8 minus 2. So that is equal to factorial 7 into 6. So same thing. So you can think in both ways. So I think this one is much better. Now come to the second question. Second question, in how many ways 7 examination paper can be arranged and paper 6 and paper 7 are never together. So 7 paper is there, P1, P2, P3, P4, P5, P6 and P7. This should be never together. So you make a space for these two, P2, P3, P4 and P5. So here is space, 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 and here is space. So total how many space? 6 space. In 6 space, P6 and P7 can be kept anywhere. So what is the way? So this book can be kept at how many places? 6 places. So 6, and these books can be kept in remaining, that is 5 places. So 6 into 5. And this P1, P2, P5, P4, P5 can be arranged in factorial 5 way. So this will be the answer. That is factorial 5 into 6, that is factorial 6 into 5. So this is the answer. Now come to the question 3. So here in family, 3 brothers, 5 sisters are to be arranged in a photograph in such a way all brothers sit together. So all brother 1, brother 2 and brother 3. This will all sit together. So take it as one entity. And sister 1, she can go anywhere. 3, sister 2, 3, sister 4 and sister 5. So total is 1, 2, 3, 5 and then 6. So that will be factorial 6. And but this brother can be arranged themselves, no? Like B2, B1, B3 or B2, B3, B1. Something like that 6. So that will be factorial 3. So total answer is factorial 6 into factorial 3. So that is equal to 4320. 4320. Now no two brothers sit together. So no two brothers sit together. That means you have to create a space for the brother. So S1, S2, S3, S4, S5. So how many space can be created? 1, 2, 3, 4, 5, 6. So in 6, two brother has to, three brothers has to go. So first brother will go in 6 way. Second brother will go in 5 places. Four brother, four spaces there. And sister themselves can be arranged. So that is equal to factorial 5. So this will be the answer. So 5p3 into factorial 5. Yeah. So that will be 120 multiplied by 120. So 14400. So that will be the answer. Now we'll solve few questions from exercise 3.3. So that is factor np6 divided by np3 equal to 120 by 1. So np6 means factorial n divided by factorial n minus 6 and factorial n divided by factorial n minus 3 is equal to 120 by 1. So this one get cancelled. So again this will be factorial n minus 3 divided by x, so that n minus 6 is equal to 120. So that is equal to n minus 3, n minus 4 and n minus 5 into factorial n minus 6 divided by factorial n minus 6. So this will get cancelled and this is equal to 120. So now n minus 3, n minus 4 and n minus 5 is equal to 120. So if you open the bracket, then it will be cubic equation. So it will be very difficult to solve. But one thing we can observe, these all are consecutive numbers. So here we can also factorize in such a way that there should be only three factor and consecutive. Then we can easily can say that n minus 3 is what. So first you factorize this. So this one is 5 into 4 into 3 into 2. So 5, 4 is consecutive and we want only three consecutive numbers. So 3 to multiply. Then it will be 6 into 5 into 4. So which one is bigger? This n minus 3 is bigger. So n minus 3 will be 6. So n minus 3 is equal to 6. So n is equal to 9. So answer is n is equal to 9. Now come to the second question. Second question says, second question, a factorial m plus n divided by factorial m plus n minus 2 is equal to 56. So how this you can write? You can write factorial m plus n into factorial into m plus n minus 1, and that will be factorial m plus n minus 2 divided by factorial m plus n minus 2. So this factorial will get cancelled and that is equal to 56. So these are also consecutive number. So this you tell factorizing the consecutive number. So that will be 8 multiplied by 7. That means m plus n is equal to 8. So this is the first equation. Now take this one. So accordingly this one will be m minus n into m minus n minus 1 will be 12. So 12 means 4 into 3. So this is also consecutive. This is also consecutive. So m minus 3n is equal to 4. So m minus n is equal to 4. M plus n is equal to 4, 8. So this get cancelled. 2m is equal to 12. So m is equal to 6. You put 6 here. Then n is equal to 6 minus 4 is equal to 2. So this is the answer. Now come to the question number 3. So 3 is factorial 12 divided by factorial 12 minus r minus 2 divided by factorial 11 divided by factorial 11 minus r minus 1. So that is equal to 3 by 14. So this will get cancelled and this will be 12. 12 into factorial 11. So this will get cancelled. And this also you can 4. So 4 into minus minus plus. So 11 1 12. 12 minus r divided by minus minus plus 14 minus r is equal to 1 by 14. So this one will be 4 into factorial 12 minus r divided by factorial 14 minus r, sorry, 14 minus r and 13 minus r and then factorial 12 minus r equal to 1 by 14. So this will get cancelled. So 14 minus r, 15 minus r, both are consecutive and 14 into 4. So 7 into 2 into 4. So 8 and 7. This is also consecutive. So 13 minus 8, 13 minus r is 14 minus r is bigger. So 14 minus r will be 8. So r will be 14 minus 8 is equal to 6. That is 6. R is equal to 6. Now come to the question number 4. Okay, question number 4. Question number 4. So question number 4 is n plus 1 into factorial n divided by factorial n minus r. So this should be n plus 1. So n into n plus 1, that is factorial n plus 1. That we can write in numerator, and denominator we have to bring r. So n, so you do one thing, you multiply n minus r plus 1 in numerator and as well as in denominator. So that you have done. So now n minus r. So here you can write n plus 1 minus r into n minus r. This one here, this side you will take. So this, if this will make, then what will happen? N minus r plus 1 factorial n plus 1 divided by factorial n plus 1 minus of half. So this one and this one is same. This one and this one same, then n minus r plus 1 n plus 1 p r. So this will be the, so this is RHS. Root. Now we'll be solving some word problem. It is four letter words formed using letter in a Madhuri. If the letter can be repeated. So you have to four letter word. Four letter word. Can be repeated. So how many ways? One, two, three, five, six, seven. Seven ways you can write here. Here also seven ways you can write. Here also seven ways you can write. Here also seven ways you can write. That is equal to 7 to the power 4. So 7 to the power 4, that means 343 multiplied by 7. So 7 cube is exactly 3. So that is equal to 2401. So 7Q is, this all you remember. 7Q is 343, 74 is 240. So now letter cannot be repeated. So letter cannot be repeated. That means here how many ways? Here 7 ways. Here 6 ways, 5 ways, and 4 ways. So that is multiplied, and this will be 840. This will be 8. So answer is 840. Now come to the this question. Algorithm. So vowel are always together. So how many vowel is there? So this one is vowel, this one is vowel, or this one will use. That means three vowel. And how many consonant? One, two, three, four, five, six. So in that always together. So what you will have to do? You all together make one entity. Like A, O, I is one entity, and remaining L, G, R, T, H, M, another entity. Then total 1, 2, 3, 4, 5, 6, 7. So you do one thing, and total is 7. So you can arrange in what way? Factorial 7 way. But this also you can arrange, no, like OAI or OIA. So see, this is factorial 3 way you can also arrange. So answer will be factorial 6 into factorial 3. So factorial 6 into factorial 3 will be how much? This will be 30240. So now come to the B. B. No two vowels are together. So no two vowels are together. So you can think of like this factorial. See how many are there? Factorial 9 minus factorial this one 30. But this is wrong. Why wrong? Why here you are doing no, all three vowels are together. Vowels are together. So two vowels are together is not excluded. Vowels are together, that is not excluded into that. So what you will do? So you do one thing. First you write this one and create a gap of this. Like first is consonant, then again consonant, then again consonant, then again consonant, then again consonant, and this consonant. So where vowels can we put? Here, 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 here. So how many places are there? One, two, three, four, five, six, 7 places are there. So vowel can we put in this one is how many ways? So suppose one vowel A will take. So A will take any place. So Seven wedge are there to put A. So seven wedge. Then one space is occupied. So O where you can put in six wedge and I you can put in five wedge. And this consonant in can we put in factorial six wedge. So answer will be factorial 6 into 7 into 6 into 5. So this you can write 7p3 also. 7p3. So factorial 6 into 7p3 equal to how much? Will be equal to 15100. So this is the answer. And consonant are on even position. So consonant on even position. So how many even positions are there? So even position here, this one is 2, this one or yes, right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one is even position. 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 So consonant has to be put on the even position. So how many consonant are there? Six consonant. So six consonant you have to put on the even position. So how you will put it? So this even position you put in six ways because six consonant is there. So either of any you can put here you can put in five ways. Here you can put in four ways. Here you can put in three ways. So four consonant gets consumed. So how many vowel is there? Three vowel plus two consonant. That you can put anywhere. So how many places are remaining? That is five places. So five place and five alphabet is there. So five. So that will be 5p5. That means factorial 5. And into 6 into 5 into 4 into 3. That will be equal to 43400. It is equal to 43200. So this will be the answer. Now this is the question number. Now first come to the question number D. So this is very easy. O is the first and T is the last letter. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have already put and T have already put. So remaining is 7. So 7 and your 7 letter also that will be factorial 7. So factorial 7 will be the answer. So factorial 7 is how much? 5040. So 5040 the answer. Now we will solve some more problems. In group photograph, 6 teachers are in the first row, 18 students are in the second row. There are 12 boys and 6 girls among the students. If the middle position is reserved for the principal and no girls are together, find the number of arrangements. So 6 teachers are there. 1, 2, 3, 4, 5, 6. And here principal position is intact. Now no two girls should be together. So if no is together, then must see opposite. Opposite means boys. So make place for the boys. So 12 boys. So you have to make 12 place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 12 by position is made. So where will be the girl position? Here will be the girl position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 girls position, and 12 boys position, and 6 teachers position. So 6 teachers position, factorial 6, and boys factorial 12, and only 6 girls are there. So it will be fixed into 13, 12, 11, 10, 9, and 8. That means 13 P 6. So this you calculate, you will get how much? Factorial 6 into factorial 12 factorial 13 divided by factorial 13 minus 6. So that is equal to 6 into factorial 12 into factorial 13 divided by factorial 7. Factorial 7 you can write it like 7 into factorial 6. Factorial 6, 6 get cancelled. Then the solution will be 12 into factorial 3 divided by 7. So this is the answer. Now come to the question number 8. Find the number of ways so that letter of word history can be arranged for A, Y, and T are together. So together, then you make it one entity. So Y and T, one entity. Remaining is H, I, S, O, R. So this is 5. So total 6. So the 6 means factorial 6. And this YT can be written as TY also. So this will be factorial 2. Factorial 6 into factorial 2. That is equal to 1440. Second is Y and T. Y is next to T. So total how many? This 7. 1, 2, 3, 4, 5, 6, 7. And Y is next to T. So Y can be either as this way or this way or this way or this way or and one more. So that is total 6 way. 1, 2, 3, 4, 5, and 6 way. So T and Y can be placed in the 6 ways. And remaining how many places are there? 1, 2, 3, 4, 5 places are there. So 5 remaining letter can come in factorial 5 way. So factorial 5 into factorial factorial 5 into 6. That is equal to 720. Now come to the question number C. There is no restriction. If no restriction is there, then we say factorial 7 because 7. So question number D. Began with began and end with the vowel. Began and end with the vowel. So began and end is fixed. So how many vowels are there? 1 and 2. Only 2 vowels are there. So 2 vowels can be written as O and I or I and O. So 2 way and remaining 5. So factorial 2 into factorial 5. So answer is factorial 2 into factorial 5, that is 240. Now in Ind is ST. So in ST. So remaining 5 ST. So this is fixed already. So 5 then this is 5 factorial 5. Now begin with S and end with T. So again F began with S and T. So remaining 5 then this will be also factorial 5. Now come to question number 9. Find the number of arrangement of letters in the word Solapur so that vowels are placed alternatively. So how many vowels are there? Solapur. So three vowels are there and four consonants are there. This is four consonants. So it should come alternatively. So the place of it. So vowels here it can be placed. It can be placed here. O A U. The consonant can be placed here. Consonant. So this is factorial 4 into factorial 3. That is equal to 144. So vowel and consonant are placed alternately. So this is a vowel or consonant. Only if it is vowel would have been there, then is can be like this also. Consonant, consonant, vowel, consonant, vowel, consonant, vowel. This also can be written, no? So alternatively, both consonant and vowel. Then this way, factorial 4 into factorial 3. Now come to the question number 10. Find the number of 4-digit form using 1, 2, 3, 4, 5 if the digits can be repeated. So 4-digit 1, 2, 3, 4. How many numbers? 1, 2, 3, 4, 5, 6. Then 6 to the power 4. Here 6 way. Here also 6 way. Here also 6 way. Here also 6 way. Then 6 to the power 4 way if repeated. Digit cannot be repeated. That means here 6 way, here 5 way, here 4 way, here 3 way. That is 63. So that is equal to 360. 63. 63. 63 factorial 6 divided by 6 minus 3. That is factorial 6 by factorial 6 by factorial 3. So 6 into 5 into 4 into that is 3 to 1. 3 to 1 this get cancelled. That is 121. This is 121. Digit can be repeated, digit cannot be repeated. So now come to the question number 11. How many numbers can we form zero repetition so that resulting number between 100? That means three digit numbers. So three digit number, but zero cannot be a first. So it is five edge. So if one digit gone, then there will be only one, two, three, five, six, five edge. So only this one is four edge. So that is equal to 100. Now we will be solving few more questions. Like six digit number using the digit 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Without repetition. How many of these numbers are divisible by 5? So it should be divisible by 5. That means last digit should be 5. So how much space is for the 5 digit only? So total 5 digit, last is already fixed. So factorial 5. Factorial 5 is 120. How many is not divisible by 5? The total number can be divisible. Not total numbers will be factorial 6 and divisible by 5 is factorial 5. So factorial 5, 6 minus 2 is 5 into factorial 5. So that is equal to 600. So a code word is form a different English letter by two non-zero distinct number, two zero distinct digit. So find the number of such code. So such code how will find? So two letter. So letter how many is there? 26. So 26 into 25. And non-zero, how many non-zero distinct digit? That is 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 9 distinct digit. So here will be 9, 9 to 8. So that will be equal to 46800. And also number such that is the end with the even digit. So even digit is 1, 2, 4, and 8. So 2, 4, 8, that is 3. So 1 gone, then 9 will reduce to 8. This will remain 26 into 25. So that will equal to 30800. So now come to the question number. Find the number of ways in which 5 letter can be posted in the 3 post box. So 3 post box, 1, 2, 3. And letter is L1, L2, L3, L4, L5. So this letter you are lifting and you are putting either in this one or this one. So how many ways? Three ways. So this letter also you either put this one or this one. So that is again three ways. This letter also you can put here, you can put here, you can put here. So that is also three ways. So this letter also similarly. So total 3 to the power 5 ways. That is 343. Now come to the question number 15. Find the number of arranging 11 distinct objects taken 4 at a time so that a a specified object always occur. So 10 of distinct object plus 1 a specified object. This you have to take always. So this always you have take and taken four at a time. So this always this also find object you can put either here or here or here or here. So four place, four method, and remaining 10 can go at any place. So that means 23. So that is 4 into 10 into 9 into 8. So this will be the answer. Now come to the 5040. Right? Say that. Okay. 1053, 4 into 1053. Okay. Now come to the never occurs. So that will never come. So never come, then what will happen? So that will never come. So only 10 object is there and 4 place. So 10 P4. So 10 P4 answer is 10 into 9 into 8 into 7. That is 6. That is 5040. This is the answer. Now come to the question number 16. In how many batch 5 different books can be arranged in a safe? There are no restrictions. So 5 different books, no restriction, factorial 5. So factorial 5 will be the answer. And the two books are always together. So two books, one, book two, book three, book four, and book five. So book five will be always together. So that is factorial 4. So factorial 4 and two books can be written as E5, E4 also. Factorial 4 into 2 into factorial 4. So, so that will be equal to 48. Now third, two books are never together. So two books are never together. That means never together, then remaining book one, book two, three. What is the places of book? One, two, three, four. So four places for book four and five, and the remaining three places for. So two books are always together, two books are never together. So this will be four. Four P two into factorial three. This will be the answer. Factorial three. So this will be the answer. Yeah. So what will the answer? Factorial 4 into 6 is equal to 72. 72 is the answer. Now come to the question number 17. I think this is the last. So three boys and three girls are seated in a row. How many ways this can be done? There is no restriction. So no restriction for factorial 6. There is a girl at each end. So girl position is fixed. So how many? Four will remain. So here, which how many ways you can sit girl? So here three girls, no, three ways. Here how many ways? Two ways, and remaining factorial four ways. So factorial four into three into two. So that is 144. Second, there is girl at each end. Third, boys and girls are alternate. Boys and girls are alternate. So one boy, one girl, one boy, one girl, one boy, one girl. Or one girl, one boy, one girl, one boy, one girl, one boy. So this you can write in factorial 3 into factorial 3. And this is 2 way. So that you multiply by 2 way. So answer will be 6, 6, 17. 6, 6, 1, 2, 2, 17. Now fourth. All the boys are sit together. So make girl is sit here. All the boys B1, B2, B3, 1 in B3, B1, G2, G3. Total factorial 4. And 3 boy can sit in factorial 3 by factorial 4 in factorial 3. That is 144. Thank you.